Hi, this is the start of our work through uh, the problems in theme 14, looking at geological maps. Now, they are amazing things, geology maps. They are works of scientific art that show us the, um, the geology that lies just at the surface of the Earth. The colours and the patterns uh, show us the internal structure of the rocks that we find. We can see how they relate to each other, we can see their ages, we can work out what's going on underground. So we can actually um, start to see things that can't be seen. Now, to do this, we need to um, start to understand how these maps work. To do this, we're going to start looking at Map A on pages 6 and 7 of the Theme 14 booklet. This diagram is what we call a block diagram. It shows us the three-dimensional geology of an area. So we can see the side view underground and also the top view. And it's that top view that's the geological map. So if we were looking at this particular block from directly above, what we see is this. This is the geological map. What we need to do as geologists is to be able to look at that geological map and to be able to interpret it as that block diagram. Now, usually we don't draw a block diagram. What we draw is a cross section, which is a slice through the ground. So if you like, the cross section are the sides of the block diagram, just in different directions. But we can work all of that out from the information that we can see on that map. You'll see that there's a key. You'll get this with any map of different symbols to show different rock types. It's really important that we remember what type of rocks we're looking at with these keys. Okay, there isn't a standard set of symbols. You'll see some common ones coming up again, but you always look at the key to tell you which rock is which. But it's really important, to, for example, to be able to recognize the difference between igneous, sedimentary, and metamorphic rocks, because that can determine how you'd actually interpret them. Now, when we look at this map, we will be looking at how we can actually work out what's going on underground that we can't see right at the surface. We also need to think about how we actually go about measuring things on geology maps, usually using a strip of paper, but we'll get to that a little bit later in the course. But a map is only really showing us the two-dimensional pattern at the surface, the view looking straight down. We assume that all the tedious soil and vegetation has been scraped away with the bulldozer, and what we see on the map is the bedrock that will be left exposed at the surface. We do get some clues, though, about what's going on underground. We have the dip of the beds that's shown with these arrows and the angles of inclination. We do get the pattern of outcrops, the pattern that each of these rock types makes at the surface. So, for example, to be able to interpret the andesite shown on this map as a dike. And we also get faults that are shown. Dashes, arrows on faults can show us which way they've moved. From all this, it's possible then for us to draw a geological cross section. And this is an imaginary slice through the ground between these 2 points labelled X and Y on the map, showing where these rocks get to the surface and showing as well what's going on underground. Now, You have block diagram A and map A to work with. What I'd like you to do now is I'd like you to work through question 1 on page 7. Can we apply some of the lessons we've learned from previous themes to actually interpreting the geology of this area? Have a go at that now. We'll talk about the answers in another lesson. I'll see you then.